Now we'll be moving on to definite integration. Imagine a curve like this. And imagine you're trying to find the area, this area. Now you could approximate this area by doing a bunch of rectangles like this. And you have to imagine for this that they're all the same width. So you'd say it's a certain distance, a certain change in x along, and obviously the height will just be whatever y is, because that would be the point on the line, which would be y, right? And the area of each rectangle would be, so then it would just be a sum from this point A, this point B, of all those things. And we can just make it more accurate by doing smaller bars. So then, as x becomes smaller, it becomes more of a dx, a tiny change in x, and this blocky sum becomes a smooth integral sign between a and b. The definite integral of y between a and b with respect to x. And so that is why the area under a curve is just equal to the definite integral between two parts. So 3x squared and the distance between 1 and 2 will be equal to the definite integral between 1 and 2, 3x squared dx. And how we'd write that is, we'd apply our power rule but put it inside some square brackets. So and then we'd go 2 cubed, because that cancels out. 2 cubed minus 1 cubed. And that gives us 8 minus 1, which is 7. So that'd be 7, that area would be 7 units squared. Now, if you were doing, say, y equals x squared minus 6x, so that's like this. And it asks you to find the distance between 0 and 6. Then you would have to do an integral dx, and then that's equal to x cubed over 3 minus 6x squared over 2 between 0 and 6. And so that would be 6 cubed over 3 minus 3 times 6 squared minus 0 cubed over 3 minus 6 times 0 squared over 2. And then so you would end up with 72 minus 108, which is equal to minus 36. And it's minus because it lies below the x-axis, but in your final answer you would just call it 36 units squared. There is a slight issue when you have a curve like this. And if it told you to find the area of the shaded region, what you would have to do is you'd have to evaluate this first and then this second and then add them together. Add the absolute values together, add the positive values together. Because otherwise if you just did it alone, part of it will cancel out. And sometimes it might not give you all the points of intersection, so you have to find that yourself. And then the other thing that you should know is how to find the area enclosed with a curve and the y-axis. So basically what you do is, say you've got something like y equals root 2x plus 1, and that's honestly more like this. You wanted to find this area, say between 1 and 3. What you would have to do is you'd have to rearrange to get x in terms of y. And then we would integrate this between 1 and 3 in terms of y, with respect to y. And then we'd do the same thing as usual. We're doing our reverse power rule. And then that would give us, okay, so it's 27 over 6 minus 3 halves minus 1/6 minus half, so that's plus a third. So then that's equal to 27 over 6 minus 9 over 6 plus 2/3. 18 over 6 plus 2/3, that's 20 thirds. And that would be units squared. And the same thing applies as sometimes you may need to make fractions into negative powers or something like that, and just get it into a sum of terms raised to a certain power. A polynomial is what you would call that, and then you'll be able to integrate that easily by the power rule.